Welcome to the MuAnalysis video on recognizing wirebond failures. MuAnalysis is a failure analysis laboratory. This video will discuss types of wirebonds, their geometry, materials, and how to recognize failure modes. There are many different wire-to-pad pairings. Most wire bonds used today are thermosonic bonds, either ball, wedge, or both. The background is a scanning electron microscope image of a decapped silicon integrated circuit. On the left, we see gold ball bonds to aluminum pads on the die, and on the right, a gold wedge bond to a copper trace on the package. Depending on the semiconductor device, power levels, frequency, and other parameters, various combinations or wire-to-pad materials will be used. Gold and copper wires are used in silicon devices. Gold wires to gold pads are used in 3-5 devices such as gallium arsenide, chips, lasers, and LEDs. Aluminum wires to aluminum pads are used in high-power devices such as IGBT and power MOSFETs, and they use wedge bonds. This is a cross-section of a good ball bond. The left image is optical and the right is a scanning electron microscope image. During the thermosonic bonding of the gold bond wire to the aluminum pad, the two metals mix and form a thin intermetallic region. These are ball bonds from plastic encapsulated devices that have been stored for 1,000 hours at high temperature. This has caused the intermetallic region to expand. The higher the temperature, the greater the expansion. This part uses a non-hermetic metal lid. In non-hermetic metallic packages, bond wires are not under compression. During high temperature storage without compression, the intermetallic grows in an uncontrolled fashion. When a wire is loosely attached to the pad, it will eventually separate at the voids. Purple plague is one of the phases in the intermetallic region. It is named after its characteristic color. Since the industry has moved to direct bonding of chip on board without any encapsulation, we see purple plague more often. Purple plague was thought to cause wire bond failures. However, purple plague normally occurs and is conductive. The root cause of the failure is due to the voids. Cratering is a cracking of the dielectric under a pad. Cratering is caused by improper setting of the bonding tool. When the crack is completely under the pad, it is not visible using a microscope. This cratering was discovered using cross-section. Sometimes it is possible to see cratering-induced defects by pulling the bond wires. The left pad has deformation and cracking, and possibly cratering. The right pad shows how a healthy bond wire should fail in pulling, by breaking at the neck. These are two examples of failed parts. The left bond wire is completely severed. The right is partially separated. Compound semiconductor devices typically use gold bond pads and gold bond wires. With gold on gold, no intermetallic region forms. If the gold bond pad is contaminated, failures will occur. In LEDs, bond wire failures are more prevalent on the anode side. Although the cathode and anode bond wires carry the same current, the anode bond wire is hotter because of its proximity to the multiple quantum well, which is where the voltage drop occurs and heat is generated. Here we see a cross-section of a wire bond failure. The top shape is conical section due to the bond wire being distorted out of the plane of the cross-section. When we see this conical shape, this means that this is not a failure. The bottom shape is more square. This indicates that the failure occurred here. This wedge bond failure occurred under the wedge bond and is only visible in cross-section. These photos were taken throughout a polishing sequence. We can see that the wire bond has lifted and is making intermittent contact in only a few places. In summary, we have seen several examples of wire bond failures and looked at methods to determine the root causes. Thanks for watching.